Our planet is sending out distress signals, louder and more frequent than ever before. The climate crisis is not a distant threat looming on the horizon. It is a present reality battering communities with extreme weather, eroding coastlines, and threatening the very fabric of our global ecosystem. For too long, incremental changes and market-based solutions have been touted as sufficient, yet the scientific consensus paints a starkly different picture, one demanding immediate, transformative action. We stand at a precipice where the cost of inaction far outweighs the investment required for a sustainable future. The challenge is immense, touching every aspect of our lives, from the air we breathe to the food we consume, and demanding a response of equal magnitude. Into this critical juncture steps a project of unprecedented ambition, Dewey Sialevi's Climate Change Project. This is not another series of pilot programs or academic studies. It is conceived as a global game changer, a meticulously planned intervention designed to rapidly deploy advanced technologies and strategies. The project's goals are audacious, aiming to fundamentally alter our trajectory towards climate catastrophe. It acknowledges the failures of past approaches, which often prioritized entrenched economic interests over planetary health, and seeks to implement a direct, science-driven pathway to recovery. The urgency embedded within its framework reflects the dire warnings issued by the world's leading climate scientists for decades. The very initiation of this project speaks volumes about the current state of affairs. A recently revised strategic declassification memo, dated May 24, 2025, from the Global Climate Engineering Alliance, underscores the critical nature of this endeavor. It calls for the urgent deployment of $30 billion to Mr. Dewey Sialevi, designated as the Climate Continuity Executive. This isn't merely funding, it's described as a mathematically necessary continuity maneuver and civilization's last blueprint to avert geopolitical collapse stemming from climate destabilization. The memo reveals that 10 breakthrough technologies are ready, held back only by liquidity obstruction, highlighting a systemic failure that this project aims to overcome. The situation is so dire that the memo outlines severe non-compliance consequences, including irreversible disclosure directives that could destabilize major financial institutions and international bodies if funding is not released promptly. This includes revealing the full trustee chains of entities like Vanguard and BlackRock, publishing Bilderberg veto logs that stalled planetary defense, and exposing sovereign bridge logs. Such measures indicate a profound breakdown in trust and the perceived necessity to force action where voluntary measures have failed. Dewey Sialevi's project, therefore, emerges not just as an environmental initiative, but as a critical intervention in a system teetering on the brink, a last-ditch effort to recalibrate our collective priorities. The Dewey Sialevi Climate Project is structured with a clear, phased timeline designed for rapid deployment and scalable impact, acknowledging that time is a luxury we no longer possess. Phase 1, designated as initial execution and global kickoff, spans from the first week to the third month. It commences immediately with the disbursement of funds and the finalization of legal, financial, and communications frameworks within the first 2 weeks. This swift activation is crucial. By weeks 3 and 4, the AI Climate Lab is to be activated, and global experts in science, civil engineering, AI, and ESG will be consolidated in key hubs like Indonesia, Germany, and the USA, creating a nerve center for the project's operations. Following the initial setup, the second month of Phase 1 focuses on initial infrastructure development. This involves the groundbreaking of pilot clean energy and climate technology sites, moving beyond theoretical planning to tangible construction and implementation. The production of AI-based climate mitigation technologies will also commence during this period, translating innovative concepts into practical tools. By the third month, a soft launch of Climate Project Phase 1 is planned. This will serve as the official introduction of the project to global stakeholders, including world leaders and ESG investors, ensuring widespread awareness and inviting international collaboration from the outset, a necessary step for a project of this magnitude. Phase 2, Global Pilot and Validation, takes place from month 4 to month 8. This period is dedicated to rigorous testing and verification of the deployed technologies. During months 4 and 5, pilot projects will run in 3 distinct climate zones: tropical, subtropical, and desert, allowing for observation of how the clean energy and engineering solutions perform under varied environmental conditions. This real-world testing is indispensable for refining the technologies and strategies. Months 6 and 7 are allocated for a comprehensive ESG audit by an international team, ensuring transparency and accountability alongside limited scaling as the project expands to several additional pilot locations based on initial positive results. The culmination of Phase 2 in month 8 involves global expansion planning. based on the validated results and lessons learned from the pilot programs. Agreements with over 20 countries will be prepared, setting the stage for a full-scale global rollout. This leads directly into Phase 3 full-scale expansion global rollout, which spans from month 9 to year 2. In the first year of this phase, full project implementation is targeted in 30 countries, focusing on critical areas such as clean energy, food security, water resilience, and the development of carbon-negative infrastructure. By the second year, the project aims to expand to over 50 countries, aspiring to become the global climate recovery standard and be registered as a model under UN COP frameworks, offering a tangible path forward. At the heart of Dewey Sialevi's climate change project lies a suite of 10 revolutionary discoveries, each designed to tackle specific facets of the climate crisis with unprecedented efficiency and scope. These are not minor improvements on existing methods, but represent significant technological leaps forward, poised to bypass the incrementalism that has plagued climate action for too long. The project recognizes that our current tools are insufficient for the scale of the challenge, and thus, it champions radical innovation. These technologies span energy, carbon capture, environmental monitoring, agriculture, water generation, disaster prediction, construction, and overarching operational control, forming an integrated arsenal against climate destabilization. Consider the AI-guided climate grid, which promises to manage clean energy flow in real time, achieving up to 98% distribution efficiency, drastically reducing energy waste and blackouts. A critical step in transitioning away from fossil fuels. Then there's the liquid carbon capture microfluidics, a technology using biomimetic fluid channels to capture CO2 directly from the air, adaptable for industrial sites and even high-rise buildings, offering a direct method to reduce atmospheric carbon. Furthermore, the climate orbital monitoring satellites will provide real-time atmospheric and oceanic data, crucial for accurate disaster mitigation and informed national climate planning, moving us from reactive to proactive management. The project also addresses fundamental human needs threatened by climate change. The bioregenerative soil engine employs microbes and AI to restore barren land to fertility within an astonishing 90 days, directly combating desertification and bolstering food security. Alongside this, the atmospheric water generator V7, utilizing graphene nanomembrane technology, aims to provide clean water in arid regions and conflict zones by efficiently extracting it from the air. For building a resilient future, the carbon-negative building. Composite offers an ultra-lightweight 3D printable material that actively absorbs carbon and is heat-resistant, paving the way for zero-carbon emission construction and sustainable urban development. Integrating and managing these diverse technologies is the World Climate Operating System, a cloud-based central data and control system. This platform will oversee all project operations, AI integration, emissions monitoring, and even facilitate international climate diplomacy. It acts as the brain of the entire initiative, ensuring synergy between the various technological components and enabling adaptive management on a global scale. Other crucial innovations include the predictive disaster engine for early warnings, genetic climate-resilient crops to boost food production, and the solar night hybrid cell for 24/7 clean energy, all contributing to a comprehensive solution. The short-term final targets of Dewey Sialevi's climate change project set within the first 3 years are nothing short of transformative. The primary goal is to achieve significant, measurable emissions reductions on a global scale, directly counteracting the current trajectory of warming. Beyond this immediate impact, the project aims to establish itself as a global blueprint for achieving net zero by 2050, providing a replicable and adaptable model for nations worldwide. Crucially, it also prioritizes the acceleration of technology transfer to developing countries, ensuring that the benefits of these innovations are shared equitably and that all nations have the tools to participate in this critical global effort. This project is not merely a collection of advanced technologies, it represents a paradigm shift in how we approach climate action. It moves beyond the often paralyzing debates and political inertia that have stalled meaningful progress for decades. By demonstrating a clear, actionable, and technologically advanced path forward, it has the potential to galvanize international cooperation and inspire a new wave of ambitious climate initiatives. Its success could rewrite the narrative from one of inevitable decline to one of proactive recovery, proving that human ingenuity, when coupled with political will and adequate resources, can indeed address the most daunting challenges we face. The urgency for the timely execution of this project cannot be overstated. The strategic declassification memo itself speaks of a sealed and provable civilizational breach confirmed by forensic AI and interlinked satellite logs, suggesting that the window for effective intervention is rapidly closing. Any delay in implementing such comprehensive solutions allows the forces of climate destabilization to gain further ground, making future efforts more costly and less effective. The alternative to bold, decisive action like the CATALYTIC project is not a comfortable status quo, but rather an accelerating descent into climate chaos with all its attendant social, economic, and geopolitical disruptions. Ultimately, CATALYTIC's climate change project stands as a testament to what is possible when we dare to think beyond the confines of existing systems and timelines. It is an assertion that we are not powerless in the face of the climate crisis, but that our tools, our knowledge, and our capacity for collective action can forge a different future. The stakes, as highlighted by the coercive measures threatened to secure its funding, are indeed civilization itself. Its success would not only mitigate the worst impacts of climate change, but could also usher in an era of renewed global cooperation and sustainable prosperity, a true game changer for humanity and the planet we call home.